This is the session from HashiCorp where we're going to talk about running and scaling agentic AI applications in production. And with that,
my name's Cole Morrison. I head up our brand story function and am our principal evangelist at HashiCorp. And
my name is Kyle Ruddy. I lead up product marketing for HashiCorp.
So we've been doing this for quite a bit. Kyle, I think I came up mainly through the software side and then kind of got tired of dealing with your type and was like, I'm going to learn the ops side.
Wow, harsh. Shots fired already.
Yeah. But you came up mainly through the ops side.
Correct, yeah. Yes. Yeah, I was big on the system engineering side, starting from help desk, kind of pretty much migrating my way all the way up through systems engineering and getting into kind of like this whole like DevOps concepts.
Yeah.
So much stronger on the operations side when it comes down to the dev and the ops.
Which is kind of funny because like that's that whole bridge between things is, well, it's a story and something that we're gonna have to deal with again with, of course, don't worry, we'll say AI like 50 million times in this talk. But speaking of which, that whole thing, you know, I feel like there's a number of groups, Kyle, in terms of when it comes to AI. There's the folks that are like, this is the answer. Like, this is going to solve everything. And then there's the rest that usually are like, what, engineers, like senior engineers, your parents, and like doomsdayers that are like, let's stay away from AI. It's got all sorts of problems, right? Which group do you fall into?
I don't know. I used to be on the latter side, but I think it's starting to slowly sell me on certain types of workflows and certain types of support for various languages and what they can kind of do and add to existing workflows. So
yeah. That's how it goes. Eventually you got to adopt. But then there's a third group, and that third group are people that have just been doing this. They've been doing it for a long time, and some of them didn't necessarily even get to see what came of their work. So we've had this black and white picture up here for longer than we intended, but it's okay. We're going to talk about a little bit about, I don't know if any of y'all know who Frank Rosenblatt is. Okay, this guy was born in the 20s, and somewhere in his 30s, like most of us, he actually came into his thing. You know, he was in neuroscience and psychology, and he had this really cool idea, which was, you know, technically the human body is just like hardware. So is the brain. And if that's the case, maybe we can make a machine learn. So he got the US Navy involved, and they funded the very first machine learning idea here, and they put it on an IBM 704 mainframe, which, having spoken to some of you, I know you've got some of you for some reason have those in your on-prem basements still, which is fine. And he started doing something that we now do today. He got that machine with 400 little photo sensors to look at something and decide a simple yes or no. Now, this was really big for Frank, okay? He called it his perceptron, and he was so into it, and it was like 60s, he called it the Mark I perceptron. And this was the first case of a machine doing this. Now, if you've done any of this stuff in machine learning, you know that this is the first kind of neuron, right? Now, this took off, right? He wrote a book about it, Principles of Neurodynamics. He started getting a lot of attention. He built bigger and bigger perceptrons. And real quick, Kyle, like, have you seen a mainframe before, right?
I have.
Yeah, you have seen a mainframe before. And it's kind of funny, like, for the size they were at the time, the amount of computing power wasn't necessarily there, right? And it's taken us so many years to get there. And he kept going and going and going until eventually people started putting out papers and what, and they're like, well, this is nice, but what can we practically do with it right now? And we hit sort of this AI winter towards the 60s. And Frank, like most tech people do when we're caught in a loop, went deeper. He's like, you know what? I'm going to prove you all wrong. I'm going to take rats that I've trained, and I'm going to take untrained rats, and I'm going to try to transfer the training over to the rat by like poking them in the brain. Yeah, it didn't work. It was very controversial, probably even more now than it was. And he went off in the 70s and died a pretty early death and never actually saw his work come into play. Because what he discovered was actually the whole idea of a machine yes or no, but not just that, what's called back propagation error, in the sense that after a machine has said a yes or no, it goes back and weights all the yes or no. So if we look at something like Kyle, and you're like, Kyle, like, has a beard, right? Does he have a beard? Yes or no?
Yes or no.
Does he have glasses? Yes or no? You do that enough times, good. If the result's wrong, then we need to go back and change the weights of those. That was him, right? So if you think about what we're doing in the entire space today, That's just millions of perceptrons, and unfortunately, Frank never got to see that. But thankfully to the hype machine, well, now we've got a lot of people here because we put AI in our title, right, Kyle?
That's right. All right, so with that, let's dive into two truths. Normally this is two truths and a lie, but we don't have that much time to get into the lie. So, and really, like, the AI hype is loud. Like, that was kind of one of the things that I was talking about there earlier, where I was kind of a denier at first. Like, you have all of these promises, you have all of this capabilities of what could be, and it was loud. We heard it everywhere. Like, we made various comments at even our own events and conferences where we were like, it's not a keynote if you don't say AI. That was hilarious for a long time until like we actually started doing stuff with AI, and then it turned into not really so funny. But the technology is also real when it comes down to it, because that's just kind of where the curve of adoption really is trending towards. That we've kind of moved on from the hype scale of things, and I mean it's kind of sort of still there, but we're also now starting to get to the point where we can realize some of that value from the AI hype cycle.
Mm-hmm. I have no comment on that one. No. So the question is, where does it fit? So we had a very fun conversation with our co-founder from HashiCorp, Arman, and he had a neat idea, right? It's like, well, when it comes to Gen AI, it's obviously not a general intelligence. So if y'all don't know that, being a general intelligence is more like saying, well, what if we build a bigger skyscraper to get to the moon? Like, eventually, we're going to run out of oxygen and die, right? But it's not quite the loom, right? The Luddites are like, we don't like the loom, it's taking our jobs, get rid of it. So where is it? Where does it sit, Kyle? Because it disrupts a lot of different industries, right? It's much bigger than just some narrow disruptor. How do you see it in context of stuff?
I mean, it could be applied into many different facets, and I think that's kind of one of the areas of the hype cycle is really like, where can you apply this? And it gets into such a broad kind of capability that it's kind of permeating into every single industry. For a long time, it was kind of funny to talk about how like various industries are changing and everybody's turning into a software company, and now it's kind of the same thing on the AI side, where kind of everybody can now start using AI in various ways, shapes, and forms, and therefore, how do you then kind of control it?
But the question is, what does this mean for the ops folks? Y'all hear it reInvent because, hey, we're working in the cloud, and when we've had some folks come up into the booth, like, okay, we got agents, we got code being generated, it's coming at us faster than ever. The AI is like, it's in every single thing. What does this mean for me as the SRE? And the biggest thing we want you to walk away from today with is this.
It's just another workload. Like, that's really what it comes down to, and that's really what the session is going to be about, is trying to apply a lot of those same things that you apply within your infrastructure today is going to be just the same way that you apply that to AI, because again, it's just another workload.
Mm-hmm. But what is different? Well, the blast radius is different. Blast radius is quite different. We're going to go pretty deep, on the technical side, because we think if you understand the first principles around what's happening in the software itself, then you as the infrastructure folks are going to be able to better deal with it, right, and tell people no, or tell people yes when you'd like to. So, in terms of how we're going to get into this today, Kyle.
Yeah, so we're going to go over the two planes, the model and the ops plane. We're going to go into and talk a little bit about the blast radius that Cole was just referring to. And then how do we get to an actual known good steady state where we feel comfortable now, kind of harnessing and using and consuming these newfound AI-based workloads and apply that to our existing environment.
Mm-hmm. All right, the model plane. You know what? I think we should have probably put this slide before it. So when it comes to thinking about this new world of AI for the infrastructure and the software folks, because there's actually been a number of software folks that have come up and have been like, oh, we got to deploy this stuff now. I'm like, how are you deploying it? It's like, from my laptop. It's like, that's not good. Much like the perceptron, we're going to try to draw a line between one thing or the other. And this one thing or the other is, well, what's actually thinking okay? The brain, not to say the ops side doesn't have brain, and then of course, what actually runs. And in fact, throughout this whole talk, we're gonna always try to differentiate where those things are, because until you understand that line, it's very easy, right, to over-optimize in certain things, get the wrong ideas, or at the very worst, get up and say the wrong thing because you're not really sure where it's coming from. What are your thoughts on that, Kyle?
No, I totally agree.
All right. So, when it comes to the model plane, for the ops people, I kind of wanted to go over some of the higher level components. And I keep forgetting that this is right here, so I keep looking over here and pointing at it. But let's start with the most basic thing. If you're using some sort of model, you got the prompt. That's what you're typing in. So you've got the prompt, and then of course you have the model itself that's actually taking the thing. The model itself, for those of you who have done no research to it, is not actually a brain, despite that looking like a brain. It's the most glorified autocomplete you've ever seen. It's one of my favorite things. Like, as it goes through, it's just a standard deviation. So when you ask it what's 1 + 1, and it says 2, it just generally knows that it's just a standard deviation of it, right? So after that, there is the entire reasoning side of it. Now, this reasoning and tools kind of come into when you hear what an agent's doing, okay? So that's the heuristic that we'll get into a little bit when it's deciding, like, okay, well, generally, if someone says I have access to an HTTP tool or to like this documentation and they give me this goal, how should I reason about using those? You have memory. It's got to keep context in terms of like what's going on. Now, for the memory side of it, there's not just the actual tokens that you're passing up, which for all intents and purposes are just numerical representations of the text that you've got, right? There's also the evaluators. As it starts moving towards its goal, you got to actually check and see, are you there? These become even more important because in the world where programmers are hard coding control flow, that's a little bit more predictable. There's the supervisor pattern, right? So this is where you've got one top level agent or program or whatever that fans out to other supporting specialists. There's MCP, I got to put that on there. I mean, y'all have seen the MCP servers. Half of them are just a glorified wrapper for an API, but in general, they just make it easier to discover tools. You've got RAG, which is more or less before any prompt you do, going and preceding that prompt with other things. So for example, if you really want to get the most detailed answer on what to have for dinner tonight, just load up all of Wikipedia beforehand and you'll probably get something interesting. And then of course there's retries. Because this is an agent, because it's not a human, it might retry quite a bit. But everything I just said there, it doesn't matter to y'all if you are in the ops side, because it's just another workload. Okay, that's all it is. You're going to contain all of the chaos that is that programmer into a container, and he's much easier to deal with. I'm talking about myself in third person, Kyle.
Yes, indeed.
Yeah.
But in the end, those are just services at that point. You know, those are things that are running that's out there, things that that you need to know what they are, but not necessarily, like you don't need to know the intricate details of all of those things, or even, you know, to the depth that Cole was going into right there. On the operations side, it comes down to what's in the what's running those actual things, and that's when we get into the ops plane, and that's. Actually, I'll go one more there, because that's the things that we know. Those are the things that we know, love. They have existed for a very long time. None of those things have changed even. You know, we still need networking, we still need connectivity, we still need compute resources, we still need somewhere to run these various things. We still need memory, we still need databases. All of those things that we know and love and have been using for probably more than a decade, depending on your age, they're still there. They're still there, they're still required, they're still needed.
I have a quick question for the audience. Like, who here is actually in the data science, the software side? Who's actually the ones like coding this stuff? Right? Don't be shy. We're not going to call you out, or we will. Okay. So there's enough here where like these are now. For some of y'all, this is actually new stuff. You've been trying to avoid it, and you do need to actually like dive in and learn it. But it is, if this makes you feel better, much like the perceptron has been around for a long time, so the patterns are the same.
So then building on that, what happens with our newfound AI powers here, we have slight changes in the way that some of these things are required to operate. You know, when we think about compute now, it's not just CPUs, it's also GPUs. When we think about various identities, it's going from like me as a person, as a human, logging into something, we now have these agent things that actually are non-humans, that they need their own levels of permissions and access and those types of things. We're dealing with different types of databases, you know, instead of, you know, maybe Postgres, we're now working with vector databases. But in the end of the day, it's all the same type of high-level compute and operating offers.
So it's kind of just like a different flavor of the same thing. Obviously, the way you think about them and some of the stuff that you're going to have to change, there are going to be a few things there. But like Kyle said, it's pretty much just more of the same. All right, so here is one thing you will have to deal with as the ops folks. When it comes to if you are just using an API, right? If you're just using like OpenAI's hosted model, or if you're using Bedrock or something like that, this all becomes even simpler, because then in whatever application that your software developers are building, when they're using these, it's just another API call, probably either hitting just the post request or using like streaming capabilities, which is now in HTTP, right? So that's even easier. Well, we put cluster on here. I don't remember why. I think it was because we've been so Kubernetesified that I don't even know what life is without a cluster, Kyle. Yeah, I don't know. But we really mean runtime. Like whatever you've got your CPU and memory on, all those different things, when you have a cluster of that runtime, you can choose to put the model and host it somewhere in that, right? Now, obviously, you're going to need to put those in a different type of runtime, a GPU-based runtime. But if you're doing something like Kubernetes, you can keep them right there in the cluster, and the benefits are, of course, that it's close, right? It's going to be a lot faster. Access is going to be a lot easier to manage and the like. You can, of course, put it in an entirely separate runtime, okay? Host it on its own EKS cluster or its own EC2 instance, or however it is you want to go about that. That, of course, is going to create separation of concerns. It's going to be a little bit easier to reason about it. But, of course, there's going to be the fact that it's separate. And then there's edge devices. Now, this is actually really cool to an extent, which is, let's just talk like, Kyle, like hosting an enterprise-grade LLM, pretty expensive, right?
Absolutely, it can be.
Yeah.
I mean, there's LLMs, large language models, and there's SLMs, or small language models. And so that is one of those things that comes down to, how are you managing the resources, and where do they need to live so that you can either access them easier, access them cheaper, or do it in a more secure fashion.
And the secure side is where that really comes down to. If you've got a manufacturing factory that manufactures shaving kits, I don't know, it's your beard that's doing this for me, okay? And they're coming down a whole line here, and you've got a camera that needs to evaluate them and is trying to use a stochastic heuristic, so something like a model. You can't just shove all of GPT on that. So maybe you want to pick something like Granite, right? So IBM's got their small language model that's a whole whopping like 3 gigs, and it can stay right there. It can process a lot faster, but of course call back up to cloud. So these are kind of the 4 ways. Do you have any other thoughts on the model serving options?
Nope.
All right.
So, and I kind of already touched on kind of the 3 main problems there when it comes down to, at the end of the day, regardless of what type of workload you're dealing with, AI or not, it's really all about speed, cost, and risk. How fast can you access resources, or really how fast can your end users, your customers, if you will, access those resources? How much does it cost to maintain those levels of resources, because that's definitely something that's more and more prevalent as AI resources and AI workloads kind of evolve and work through those processes. And then last but not least, of course, it comes down to security and making sure that agents aren't running amok and having access to all kinds of insane things, driving those cloud costs up.
Yeah. Speed, cost, and risk. Okay.
All right, and that's kind of where we come into play with the HashiCorp Cloud Platform. This is one of those areas where we really like to apply a general, managed control plane where you can provide, a consistent operating model when it comes to how various teams need to generate those workloads, how they maintain those workloads, and how they, continue that throughout the entire life cycle of their existence and usage. And, I know we're at the AWS event, but however, this is something that applies to all sorts of things as well. This isn't just AWS, but you can do Kubernetes clusters. You can do all sorts of things well beyond just that. So throwing that out there. And then when it comes down to it, we've kind of touched on this a little bit already, but really what it comes down to is, this is something that we've already been through, if you will. Like as people, everybody is in here at a cloud conference, so we've all had cloud programs at some point in time of our career. we've had to go through the process of adopting certain cloud services. We've had to go through and standardize what that looks like to then build on those services and then scaling those up. And that's something that HashiCorp has been there along the entire journey. We've been around for more than a decade, releasing various products all the way back to Vagrant and all the way up to what we have today with the HashiCorp Cloud Platform. And it's really interesting that even our co-founder, Armon, he kind of likens this whole like AI adoption and AI program very similarly to cloud programs. However, the one big thing that's kind of changed in that type of aspect here is the timing. Like it's greatly consolidated. Like folks and organizations really need to go from, we have a little while to, kind of implement things on our own pace. And now it's like, no, we need this stuff up. We need it up this fiscal year or this calendar year. So how do we get to that point? And so that's where we see a lot of this rapid adoption when it comes to the AI program side of things.
But it kind of comes back to what we said again. It's just another workload. And Armon's idea and what Kyle just talked about, if you abstract the idea of an agent program into just it's a workload, well, it's a lot easier to reason about the entire thing. And so the journey is kind of complete in terms of how you're going to go about managing it. All right, so I'm going to hop over to our demo here. And we're going to walk through, if this will recognize my finger. And I click over to the thing. We're going to walk through some of the what we're going to be looking at as we talk about that. And so as demos go, and as demos go with myself and Kyle, this meant that we dug a hole and got so deep that we were like, let's just keep digging instead of making it simpler. So we did, to make sure that you all had something and we could talk very deeply about it, we have an application here that is doing a couple of things. It is, so say hi to everyone at the reInvent talk. Okay, so what we have here is we have an application that's reaching up to a supervisor agent. Now this supervisor agent, his whole entire, right, so here, he's talking to everyone. There he is. I don't know why he's a he. I decided to use a he. This supervisor's entire point is to speak to humans, to interpret human language. But in the background, it's got connection to a specialized infrastructure agent. And that infrastructure agent, while the supervisor is using a large language model, so Bedrock, to interpret all of this, in the background, it's reaching out to a small language model that we're hosting just directly on EKS, y'all. It's just in a Docker image. I just deployed it into an EKS cluster, just like another workload. It's talking to this small language, this agent that's speaking to this small language model, and it's generating, and its entire idea is, I need to interpret this, I'm going to be passed something from the LLM, I need to understand and think about the infrastructure side of it, and also I've got access to what's going on in context of our Terraform deployment in our organization. Now speaking of which, this is where we're going to use that platform that Kyle showed that incredibly beautiful slide on, which is HCP Terraform. So Kyle, just give folks a little idea of this product, how it works with Terraform.
Yeah, so HCP Terraform is essentially a hosted service that allows you to plan and apply all of your Terraform operations in a centralized service. And what we'll walk through is kind of how some of those features and capabilities are kind of brought to life as we're managing these various workloads as we go through our demos.
Yeah, and so real quick, how many of y'all here use Terraform? That's what I'm talking about. All right, so you know that the beauty of Terraform is that it is code, and as a result, when you're talking to Copilot or GPT or whatever thing, and you're using it to help generate the code, it helps represent the actual state of the infrastructure itself. It gives you a way to persist whatever it is that it did generate, whether it's good or not. Now, if you just let that go rogue here, if I come over to my little AI infrastructure agent here, and I say, hey, do stuff, it's going to do it. Now, whether or not it's going to be good or not, that's kind of the question. Well, the platform here, HCP Terraform, is going to serve as our human in the loop. It's going to be able to make it so that when we go into our actual, orchestrated workloads here, if I can find the one where I deployed the actual spaces. Oh, that's right, I deleted the application.
Yes, you did.
Yeah, I deleted it. We'll deploy it later. But regardless, if it's generated by the actual AI, we can do stuff like, look through the cost estimation and look through set up policies to make it to where even if it does spit out a bunch of code, we're only letting it through if it passes certain hoops and the like. So let's talk about the architecture a little bit here. You can see here we've got the cluster that's actually running this little AI application. So Kyle, it's just another EKS cluster, but immediately there's some differences here in terms of like the node groups. So
we have two different node groups that are down there. One is going to be your CPU node group, and the other one is going to be your GPU node group. But essentially, again, you're just managing that the same way that you have all node groups.
Yeah. So if you've never done this before, the way to think about this when you're going to go to set one of these things up, again, if you're just using like Bedrock or something like that, you can just skip the GPU thing altogether, which is the value of it, right? You just deploy a normal app, it makes API calls, and it's just another day in Kubernetes world. Now, if you want to host your own model, you're going to actually need to get a GPU instance. And in our case, we're using IBM's Granite. And the reason why we're able to do this, and this is the smallest GPU instance that AWS has, and we've got our own model running, is because Granite here is only 3 gigs, right? So it's really small. You get it up and running, and you've got more than enough. Now you might say, well, what's the difference between the small language model and the large language model? For most intents and purposes, you're not going to notice it if you're depending upon the space. It's trained on a much smaller data set, so if you start asking it really weird stuff about Reddit, it's probably not going to know it. It's going to confidently tell you something though, right? Yeah, do you have any thought on the small language models there, Kyle?
I think they're really unique in the way that you can kind of use them in various facets, and especially use them in low-cost ways. Like I've personally ran a couple of these, like the smaller LLMs or SLMs on like a Raspberry Pi. You can run that locally. You can do all kinds of really neat things with it. You can start playing around with kind of code generation in a very low-risk type of environment without incurring a lot of cost.
In fact, I've got an SLM. I've got Granite actually running on my MacBook right now. So, my battery's not even budging. So that's pretty good. Okay. So, but I will say for the agent part, you're like, well, do I need a GPU for the agent? Actually, no. The agent still sits on the CPU nodes, okay? It's just the model that's on the GPU, and now suddenly you're treating that small language model just like you're treating Bedrock, right? So that's the way to reason about these things. Pretty straightforward there. I think, and what we're going to do throughout this is we're going to use this application and this playground as a test ground just to drive our points home about the different aspects and areas of things. So let's hop back over to the slides.
All right, so that was a look at the 2 planes that we had talked about, the model plane, ops plane. So let's start talking about some of the, the various, paths, if you will, as we start going through kind of adoption and kind of what the variances kind of look like there. Now, when it comes down to the 2 of us, between myself and Cole, I find myself as the ops person that I'm probably more on the deterministic side. I won't necessarily call myself normal, but I will liken myself to, say, a normal program where you're going to have your goals, you're going to have some tools that go along with that, but you're going to have a pretty well-defined path in terms of how you go from point A to point B and trying to provide whatever value that you're trying to provide as part of a service.
Yeah, and that makes it a lot more predictable for the ops side, right? Because there's only so many control paths, so you know what's going to happen on, say, Black Friday. You kind of have an idea. You can extrapolate because it can only get so bad or good, however it is that you want to see it. But what we wanted to do here is comfort you all with the first principle of actually not a lot changes in an agent program. If you think about the business logic in a normal program, it's just saying, if A, use this tool. If B, use this tool. Evaluate if we've got it done. The only thing we're changing in an agent program, so you're not scared of it, is instead of your programmer writing a control flow for the hundreds of different ways that your customer can send you a complaint, we just give the tools to the LLM. We say, hey, this is my goal, right? I've got some tools to solve it. This is what I know about the customer. What tool do you think we should use? And it's just going to go in a loop. It's going to say, well, Kyle's asking about, shaving kits in haiku format. And it's like, okay. And it's still going to be able to figure that out better than asking your programming team to write a control flow for it. And it's going to keep going. But we have the word stochastic up here, mainly because I didn't want to use determinism again and say non-deterministic, because that would be your side. Because you don't necessarily know how many times it's going to happen. Like sometimes it's going to get it done pretty quickly. Sometimes it's going to get caught in an infinite loop. But when do you choose agents then? Because if, Kyle, like, you love determinism, right? In fact, do you believe in fate?
I greatly enjoy a fixed path on how we go from point A to point B. That's definitely how I found myself as at least I consider myself successful on the operations side of the house, was being able to follow that line.
Yeah. So the question is, well, why would you ever use one then? Well, this is where if you look at the market in terms of a lot of the new applications coming up, one of the root ideas that they're trying to deal with is messy input. All right, when you go to a form and you're filling it out and you've got a defined number of drop downs, the reality is because I don't want to deal with all of the different the ways that you could ask me stuff. I only want to write so many if statements and switch statements. But now with an agent, you can send me whatever gobbledygook you want to, and we can figure out something. So personalization, so messy input's a big one, and then personalization, the way you want to be spoken to. Okay, people get up and they talk, I don't know, for 10 minutes about. The Dodgers? Yeah.
Well, you can't say shaving kits anymore.
Yeah, I can't say shaving kids, so we'll go to baseball. You have no idea what they're saying, okay? You can get it like, hey, can you just tell it to me in plain English or whatever? Now that can actually happen. But if your developer's got to do that, that's going to be not as well. But long tail questions and edge cases. Kyle, how much do you love filing tickets and dealing with tickets for that?
As the receiver of tickets, do not love that.
Right. And that's something we both vibe on, right? We code and develop for the 80%, and then the other 20% are a non-stop stream of tickets. And then, of course, there's tons of data, tons and tons of data. If you think about the way that these things are going nowadays, tons and tons of data is a lot easier to deal with, right? It's just all pattern matching. But bigger blast radius is still, at the end of the day, all that changes here is this. If you understand those two things we just said, you can kind of fill in the blanks of everything else that we're going to do here, right? You can kind of understand. So the analogy we wanted to throw as a working through line through all of this was, think of your infrastructure and the end to it like a venue, okay? You have the rate at which people are coming in and moving about. You have the reach in terms of what they can access inside of it and out from it. And you have the resourcing, which is how big should the venue be? How much bigger should we make it? How many rooms should we open it up? How much does it cost? And the like.
It's something that we experience every day as we come into and leave this event.
Yeah, we do, don't we? So let's step into actually going through these three. So in terms of rate, Kyle, when you're looking at your infrastructure, how does that look in a normal programs world?
Yeah, so in the normal programs world, that's something that you have well defined. You know exactly what that workflow is going to look like. You're going to know that a person is going to have to reach out to, say, a web page to access something. That web page is then going to hit something on the back end that's probably a database. And then from that point, there's probably going to be some level of computation that is required. And so you know exactly the step-by-step process that workflow is going to take.
And yet on the agent side, all those things and tools and capabilities might be available to the agent, but you don't know which one it's going to try first. You generally know that if your agent walks into a kitchen, it's going to get a plate out first. But sometimes it comes down and gets the meat out and puts it right on the counter first, and it eventually gets the sandwich. And so as a result, the rate at which it does it is going to be a little bit more unpredictable. It might call the same tool 3 or 4 times as it's trying to figure it out, as opposed to just 1 time. But of course, the implications for that are the problems.
Yeah, and that's and part of the problems there is that when you kind of don't know what that path is going to be, you run into those issues of what happens when requests start queuing up, or you have too many, like, using the venue example, what happens when everybody tries to get into a keynote at the very same time and it starts flooding the system. Mm-hmm. And then at that point you have to look into, okay, so what's the response to that? If there's too many people waiting, maybe you need to bring in additional workers to then start, helping, queue the line in more appropriate terms. However, if you move workers from one place to another, what happens to the workers that were existing, and what happens to the lines at where they used to exist? Mm-hmm. Turning it into a very noisy neighbor type scenario.
Yep, noisy neighbors, good God. And there's retries too, right? We're, as humans, at least polite enough to stop asking after a few times. Well, maybe not all of us, but agents are gonna just keep going. They're just gonna be like, okay, can we get in? So, all right. So this comes down to three big problems. And in context of the through line of our analogy here, we want you to think about pacing the front door into your infrastructure. We want you to pace the number of workers that you've got going about, right? You don't want to just optimistically hire, like, I don't know how many bartenders for the venue if no one's going to show up, right? And then the retries. That's the other thing, the main things that you need to deal with as the ops people. The other stuff, and the reason we're focusing in on these, because again, those two planes, it is what can you control? Well, these are the areas that you can control without diving into the software and ever having to talk to the programmer themselves. So let's go through those. First one, pacing the front door, Kyle. So I have got a program. You know that it's going to get hammered by all sorts of stuff because we've labeled it with AI, and we've had our marketing folks pushing it out so much, like Jay Fry here is in the audience, who is one of the marketing folks. And so we've got a ton of volume coming in, but you can't touch the code because I won't let you. So how are you going to deal with it?
Well, and that's where you put levels of guardrails around that. At that point, you establish control in how many things can be processed at the same time. You start going through and enforcing best practices. You make sure that everybody has a good understanding of what they're supposed to do, what the process is going to be. This is a very similar to like a TSA type scenario where if you know that you're going through the TSA line, you're going to have to take off your shoes, you're going to have to remove stuff from your bag. It's a very similar process, just now applied to your workflows.
Are you saying that because you got stopped and specially searched when we were coming in here?
That did not help us get here on time. That was special.
Yeah, that was. And then of course from the infrastructure as code side of things, look, you're going to see this as a recurring piece, but is the module and the policy story. If you've got stuff like queues, and so me being the programmer, and we already don't want to talk a bunch, and I'm like, yeah, but I don't know what that is. You say, here's a module, go do it, right? Or if I'm the optimistic one who's like, I want to on the ops side, I'm going to just start coding up Terraform, and I'm just going to push it out the door. And you don't know about it. Well, that's where policies come into play, which actually, Kyle, maybe this is kind of a good time to like drop what policies are so we don't keep them.
Yeah, so before we get too far, this is what I was referring to when I said guardrails. So policy as code is a way that you can take, in essence, let's talk Terraform for a second. You can take your Terraform apply, you can get the results from that apply, and then push it through a set of policies that you have established as code. This allows you to say that, in certain cases, hey, you can only, deploy certain types of EC2 instance. You can only define or, have access to certain compute nodes. You can only do or have access to certain policies. Things along those lines that you can establish those as guardrails as your resources are being, prior to the actual deployment stage, but you're verifying them before they get to that deployment stage so that if you have known situations where you don't want people to apply them, you can stop them in their tracks before it ever reaches your environment. So they're really powerful. We have a bunch of various policy sets that are out there that we'll get into in a demo. You can apply them to various compliance standards, or you can build your own.
All right. So I just realized we're burning through time here, so So then the other thing is, of course, pacing the workers. If you come in and you've got all sorts of different snap and water stations, how do you make sure that you don't over-provision the number of workers? Well, we're going to get a little bit more into this later on, but it still kind of comes down to the same idea, right? You want to look at the line, you want to pace it, you want to force a line to make sure that, well, the workers are only getting so much. So let's go to the third point. And then, of course, there is the story where you are going to have to talk to your developer at some point, and those are the retries. This is how many times are you going to let an agent retry before you're like, okay, done, like chill out, go do something else. I don't know, Kyle, how have you dealt with that in the past in terms of like microservices?
I mean, you can either establish a counter. Counters are always very simple. Hey, if you do this thing more than 3 times, then we're gonna hit you with a pause. You can do it based on memory capacity or allowances there. There's several different ways that you can kind of use it. That's one of those things that comes down to having a general understanding of what your estate kind of looks like when it comes down to infrastructure and what those things are actually trying to accomplish.
There is one fun thing too, if you can ask your developers when you ask them for this, tell them to make the retry timing a little bit random, because if you don't, then they're all going to retry at the same time. And while that's very funny at best, like generally that's going to create more problems with the other services. So
I don't know, injecting uncertainty into my deterministic workflow, I'm not sure how I feel about that. But
just a little for the fun. So this comes down to the 3 main solutions to think about. Pace the front door, right? Pace the number of workers themselves and pace the retries in waves. Thoughts? And we're going to take a look at some of the stuff in the demo so we can get to the other things. Yeah?
Yep.
Okay.
Let's
so
jump into the demo.
The rate side of things, well, actually that was LA. That's actually a good thing. The rate in between there is just to mainly show this is there's a lot of different ways to think about rate. There's not just the rate at which the requests are being processed throughout your network, right? And so if we were to go to, say, our logs here and go into any one of these different logs, like around the API server or for the way that our different applications are going through, you're going to see these hammer through and do a lot more, and that's the nature of those agents trying to do a lot more work that you can't necessarily predict. But part of that's also going to be the human side. If you have someone coming in, interacting with your interface, and they're trying to build out an infrastructure, right? If they're trying to say like, okay, I'd like to deploy an app to my EKS cluster. Well, I might do this one little thing at a time, right? But I might do it in 10 steps. I might do it in 20 steps. That's a lot more retries as opposed to one web form where I take you and make you fill it all out very nicely, where you also fail a CAPTCHA, which is always oddly embarrassing for everyone. And then we get one request. We know exactly what's going to happen. So here by the way, so we see this thing right now going and grabbing information from our HCP Terraform account. So what other stuff should we? Oh, the policy side of things. If we go and we take a look at well, Kyle, I don't know how to do a queue, right? I don't know how to do something like that. We have stuff like modules that you can use, right?
Yeah, and modules are a very simple, easy way to kind of easily consume a common set of resources. So one of the things that we've kind of called modules over time is, it's kind of the building block of Terraform configurations, just because it can take some of those much longer, more verbose kind of configurations and isolate them down and consolidate them into a much more easier to consume type of block. So instead of having to generate, I didn't see how many resources are in this one, but you have 42 inputs for this thing.
Oh, yeah.
Just that one single module, and you can consolidate that all into the module block that's right there on the right-hand side. So you're taking 42 different inputs and breaking it down into literally 4 lines of code in order to get this SQS resource deployed.
So that's the human in the loop side of it, in the sense that you get to give both a carrot and a stick. They're like, hey, go use our modules. So this is like a networking, for example, where maybe we paste the reach, maybe we put a networking firewall or gateway in front of it and said so only so many things can come in. So that's the nice carrot way. Go use this approved thing. And then you can also, of course, set up policies. And this is where you get the stick side. It's like, well, you can deploy stuff, but we're going to stop it anyways. So.
Yeah, and this is where you come into having a level of permissions that are set within an environment. And the other thing that Cole was showing was also a private registry. So you have access to both modules that are in the public registry or modules that are in a private registry. And that private registry allows you to customize those resources for your particular organization or particular use case. Then getting into the policy side of the house, there are also a bunch of Sentinel policies that are available out on the registry as well. This is where we were talking about some of those compliance standards that are out there. We see the CIS version there, yep, exactly. That's out there, that's available. There's a whole bunch of policies that are available as part of that. You can easily invoke those within your HCP Terraform environment. Or, of course, because these are also publicly available on GitHub, you can also customize these to however you want to and start applying them in your HCP environment, which is what Cole was showing just prior to this as part of the policy sets. So there you can see that we've kind of consolidated those policies and applied them by resource type. So you have your RDS policy set, you have your S3 policy set, and you can do that and apply those. And you can apply those broadly as well. So you can apply these at your entire organization level or individual workspace level. But the nice part is that if there's no S3 buckets in your resources, there's nothing for it to check. So there's also not really any harm or overhead when you apply it in that type of way.
All right, so for time, let's hop back over into our stuff, and I remember we were like, are we gonna be able to fill 60 minutes? It's like, well, if we're late and we talk for a long time on one thing, maybe. So let's go ahead and hit Act 2 here. This is the reach side of things. So this is in context of what your services reach out to, Kyle. So
Yeah, so on the the quote unquote normal side, we kind of know exactly what our service is going to reach out to. Those things have been predefined. We have probably created some either IAM roles or depending upon which environment you're using, established a set of permissions in order for that we know that this thing is only going to talk to these couple services, which is kind of displayed there with the arrows.
Agents, I mean, in theory, you know what they're going to reach out to. But
well, you hope you know what they're going to reach out to, but that doesn't mean it's not a determined path yet.
Yeah, and you're like, but it's like, well, hold on. They only have access to so many tools. It's like, yeah, but what you don't know is Cole gave it access to an HTTP tool, and now it can go anywhere that it wants. So let's walk through the solutions to the reach. Well, let's name the reach problems here. Oh, right, and of course, there's many agents too. So you got to think about this, them all doing it, right? So, all right, so we have 4 main reach problems, Kyle.
Yeah, so there's the overprivileged reach.
What'd you point to me?
I mean, just natural motion right there at this point. Somebody has maybe too many permissions or too much access to all of those resources that maybe they shouldn't have access to. Unfettered tools. This is what Cole was just talking about with HTTP. You can do a lot of things with HTTP these days, and it's getting simpler and simpler as we were just walking through some of the removal of WebSocket requirements for even some of those HTTP offerings. Default open. These are just known open configurations where you just by default have access to stuff. Or then, how do you get out? So how do think about the next steps, the next iterations along that process, that agent reaching out to something, and then where does that go from there?
Nice. So let's go ahead and walk through each of the solutions real quick here for this. First up, for your agents, give them all their own identity. All right, do not give them your user credentials. Don't give them your machine's credentials. Give them their own separate credentials. Give them their own separate credentials. This makes auditing boring in a good way, right? Because you know exactly what agent was doing what, when, and where. If it's bound to your user or the machine, then you've got that all stacked up in one place, and it's a lot more difficult to deal with. Why don't you do the next one? Yeah, there we go.
Yep, and then you can bound it. So you make sure that they don't have access to tools that they shouldn't. Making sure that, if it's a specific service, it only has access to those services that you have defined that it actually should, instead of just giving it kind of, unfettered access to all the things. You actually go through and make sure that you've vetted the exact things that it should have access to, kind of still applying those levels of guardrails to those agents and workloads.
There's the outbound story too. Even though you might have an MCP server that has cleared agents to only use certain tools, we can go another certain, look, if we're putting these agents in a kitchen, what if we just don't put a knife in the kitchen at all? Well, this is the blunt force way, and this is something you all have control over. Just cut them off from a network level, from a firewall perspective, from even reaching the tool. So even if it does try, even if you've put a ticket in to say, hey, don't, to the MCP server, whoever's managing the access to that or to the software, for a fact, even if they try, the network's got cut off.
And then you get into the exit points. This is where you can consolidate those into a single gateway, so that instead of your agent reaching out into various services and those services going outbound from that point, restrict them back in so that you know where that entry and exit point actually are, and you have better control over those things because you can establish various monitoring tools and how you apply it to that process.
All right. So this is in essence how to deal with each of those problems. And again, the value of this is hopefully for the ops folks, this doesn't sound new, right? There's some new things to think about in context of how the programs are, but this is still probably stuff you're already used to. We just call them different things. We use different acronyms and the like. So I think we'll just batch the demo here at the end so we can get through this next one, which is going to be resourcing. Now this is the fun money one, right, Kyle?
Yeah, so this is how do you, going through and thinking through the kind of the deterministic workflow, we kind of know what level of compute or what amount of compute that we're going to need for that, what level of storage that we need, what level of everything else that kind of goes along with that. But when it comes down to our agent side.
The agent side, because of the two things we've talked about, because we don't know how much rate's going to happen, we can have a good idea, right? Because we don't know what's going to try to reach out to, how many times it's going to reach out to an internal service and the like. The amount and the way that we can predict the size of the instance, how much of the resource is being taken up, well, it's just as non-deterministic as the agents themselves.
And that turns us into our resourcing problems here, where we have various levels of conflictive resourcing, where you can actually set up various levels of controls along those processes. You can go through and have unmetered resourcing, which that gets into a various other topic there. And then, of course, drifted resources, which since everybody in here has used Terraform before, you, I'm sure, have experienced a drifted resource at some point in time. Similar concept, just much larger, broader blast radius.
So let's solve each of these. First one is for conflictive resourcing. This is actually pretty simple to solve. One of those, if it's a model and you're hosting your own, you probably don't have any other room on your GPU to throw it on. So that one's pretty simple. For your agents, though, put them in their own node pool. Right? You put them in their own node pool, it's a lot easier to figure things out and a lot easier to keep them from overreaching into the resources that your deterministic normal programs are reaching into. You want to take this one? Or you want to?
Yeah, you have at it.
Talk about? Okay, yeah. So the next thing is the signal-based control. So this comes down to watching what's going on with your resources. So in context of this, normally it's tempting with a deterministic program to go on patterns of what you're doing with CPU, with what's going on with the memory usage, maybe storage usage for certain cases. For the agents themselves, you really want to start looking at the queue, right? I need to decide, do I need to bring another bartender, whatever, another bartender into a bar, like a line outside, instead of saying like, well, how stressed are you, Kyle, behind the bar? Say, even though I'm concerned about your mental health, right, I actually care about how much big of a line there is. So let's actually decide if I bring someone on based on the line. So in this case, we're going to look at the number of requests coming into the agent as opposed to how stressed the agent or how stressed the actual resource is itself. And then for the last one here,
yeah, at this point it gets into, how do you kind of throttle control for those various resources, and how do you start, establishing levels of either caps or making sure that, various resources don't grow out of control and kind of get into that, unmaintainable, unmanageable type of format, because that's also how we get back to the point of having surprise builds.
Yep. Yeah, so we'll show some of that here as we get into the demo. So those are the three solutions here, but for time, why don't we go ahead and head into the last part. We're going to just show all the demo at the end here at this point. So the point we want you to take away from this is, hopefully if all of this sounds pretty familiar, it is because it is familiar. It is the same thing, right? It is just the same workflow, but just a bigger blast radius here. So again, we have the analogy up here for you, and let's do one more look at the demo here just so we can kind of see everything that's going on. So if we hop back over into into HCP Terraform here, let's see here. What is the biggest sort of win here? Well, if you have, say, a developer that has just generated a bunch of new code, and they've just gone in and they've done a Gen AI thing, like, look, I'm going to make my own S3 bucket, and they want to come over here and say provision it. So let's go into one of our projects here, and let's provision this new bucket here. So we're going to see the pretty straightforward workflow of connecting this. Come on, you can do it, thingy. There we go. And that was the example. We're just going to go ahead and create it here. Now this is the other side of the story that we haven't really touched on as much, but this is, before your developer was going to be, they're going to be looking through stuff. This time, you just went into GitHub Copilot or Cura or whatever and just got this done today. Now, if you aren't watching for it, well, this might not be very fun for you. But let me go in here and just show you real quick. If I add a variable, I don't remember what variable I needed for this. Let me see. What did I need? Oh, I didn't need any. So this is just going to try to provision a bucket in general. Oh, that's named something. Okay, we got something. We're good. Trust me, this is going somewhere, so we're going to put this in here. So if we put this in here, this is that Gen AI thing, and what we already see that is going to happen, Kyle, is something Kyle has gone and passive-aggressively done here, right? Which is
set up and established all kinds of guardrails so that while you do have access to plan out your Terraform configuration that you pulled in from your repo, it is going to apply it. Take that output from the plan that we'll see here in just a second, and then start applying some of those guardrails that we've established through Sentinel, which is our policy as code framework. So once we know those resources that are going to be created or otherwise managed, then we can start applying the policies. And you can do anything from time-based. You can pull in other information, such as what you'll see after the Sentinel policies are performed and interrogated. There's also cost estimation, so you can have a level of costing, so you have a level of awareness of what this configuration is actually going to cost in terms of cloud billing, since these are all, as we can see, AWS-based resources. And then it'll continue going on from there. And we can make some determinations based on that too. So we can take some of those as 3 policy sets. We can make sure that Cole is provisioning all of those resources through the using best practices, both industry standard-wise as well as internally as well. And then we'll also get a nice little readout of that once the plan rolls through and completes, which is taking a little longer than it probably should be, because that's just the way live demos kind of operate.
The way that they work. So as we wait for this to finish, I can go and spoil this for you, which is that I made this bucket public because I roll like that, but that's going to get blocked. But in the background, Kyle's gone and made a module for me to actually use. He's like, look, man, I know that you need like a bucket, so why don't I just give you a pre-approved module, right? And so this is where you get to this neat story to where, let's say we go to your little application here and say, like, I'd like to deploy an S3 bucket. And this is another area. If you ever get around to provisioning your own infrastructure and you want an agent to decide to do it, that's kind of a scary story, unless you think about everything we just did here. Right? If the agent's coming up with this stuff, just think of them like a rogue developer. Give them 2 big things. Here are some standard modules that you can use to build from. Only use the modules. If they're only using the modules, that means they're only using stuff that you vetted and you know is good. And then even if they're not using the modules, if you set up the guardrails through those policies, it's gonna, well, apparently in our case, oh, look, here we go. Yay. It's gonna stop. It's gonna say, hey, well, this is actually trying to make a public access bucket. And suddenly, you don't even necessarily have to have the individual standardized building blocks. You've got the guardrail set up so it can just generate Terraform. This becomes a human in the loop. Kyle can come in here and be like, Cole, and also, the cost, apparently we couldn't estimate the cost of an S3 bucket. It is empty. But there's also, we have Cloudability with IBM. We have a run task set up through them that you can add pretty easily. And Kyle, why don't you tell them about that real quick, because that is an important part of the policy story.
Yeah, so another part of a capability that you can add to your Terraform workflow here is the ability to reach out to third-party systems. And we're doing that through what's known as run tasks. And what happens is a run task takes that plan output and it can send it off to, say, Cole already introduced IBM's Cloudability offering, which is a financial operations type of tool set, so you can see some level of cost visibility through there. But you can also start using that with other security-based toolings. You can use that with like Bridge Crew and Prisma Cloud and those types. Cole was showing us the run task registry that's out there. There's drift detection, there's infrastructure management, there's policy, there's quite a different areas that are out there, because we know that you all are using other tools within your environment, and so how best can we integrate with those existing tools that you have?
Yeah. So this, of course, helps the human in the loop side of the story. This makes it so that the speed, right, having a car that goes 50 miles an hour is fun. Having a car that goes 1,000 miles an hour, that's fun. It's a lot more dangerous. But if you've got this stuff in place, what your Gen AI story is again, just another workload now. You've got the same things in place. So let's hop back over and wrap things up. And, we wrapped things up. So what we have up here is a QR code for you all. We have a lot of resources. I know Kyle and I are going to be doing a more in-depth technical version where we're going to dissect this stuff in depth, since we're kind of running over here. And we've got a little form there. If you sign up for it, you can get more resources on us in terms of infrastructure and cloud and context for the AI world. And what else, Kyle?
And yeah, please complete the session survey as well.
If you like this. If you don't.
Details.
Thank you.